Madam, please start.
Okay, sir. Good afternoon, all of you. I am Dr. Pallavi Khairmode. It gives me an immense pleasure to introduce and welcome today's resource person of today's FDP organized by SGM College Karat in association with HRDC Pune. Today's resource person of the session is Dr. Shailesh Kaushal. He is an assistant professor, Department of Business Administration, University of Lucknow. His qualifications is PhD, NET, MBA, and B. He has been invited more than 340 times as a resource person and delivered lectures on research methodology in across India. He has published more than 60 research papers in various national and international journals. His area of specialization is in marketing management, statistics, and research methodology. He has high proficiency in the statistical software such as SPSS, MOS, Process Micro, Smart, PLS, eViews, and R. He has also uploaded 116 lectures on YouTube. With this brief introduction of Dr. Kaushal, I welcome you, sir, and all the participants on behalf of organizing committee. I request Dr. Shailesh Kaushal, please share your views on hypothesis testing using non-parametric test. Over to Dr. Shailesh Kaushal.
Thank you, madam. Thank you. Good afternoon to all. I am Dr. Shailesh Kaushal from Department of Business Administration, University of Lucknow. So today I'm going to start my topic with the non-parametric test, means hypothesis testing in non-parametric test. So as we know, there are two types of test. One is parametric test and another non-parametric test. So parametric test basically assumptions based test. Before applying any parametric test, we use or apply the or checking the assumptions of the parametric test, like data should be normally distributed and data should be homogeneous and all. But in non-parametric test, when we test our hypothesis, we do not need to check the assumptions of the parametric test, because non-parametric test assumptions free test or distribution free test. Okay. Now, non-parametric tests are those tests which do not rely on data belonging to any particular parametric family of probability distribution. It means these tests are distribution free tests, and we do not need to check the normality and homogeneity of the test. Now, when to use non-parametric test? So non-parametric tests are used when assumptions of the parametric tests are not met. I told you when we use non-parametric test, we need to check the assumptions, like data should be normally distributed and data should be homogeneous. But in non-parametric test, we do not need to check the assumptions. And the equivalent of the non-parametric test, one sample. If we want to use one sample t-test and my data not normally distributed, then I should go for a non-parametric test, which is equivalent to the parametric test. And the name of this test is one sample Wilcoxon rank sign test. Now, you can see the graph. There are two picture. One is left-hand side parametric test and another that is non-parametric test, right-hand side. Now there are two sample here in a non-parametric test. So you can see here the non-parametric test, the four test, Mann-Whitney U test, Mann-Whitney U test, Wilcoxon sign test, Kruskal-Wallis test, Friedman Anova. Okay. So first of all, we should understand why should we use the Mann-Whitney U test. What is the purpose of Wilcoxon sign rank test? What is the purpose of Kruskal-Wallis test and Friedman Anova? So before coming to the non-parametric test, we should understand the concept of parametric test. One is independent sample t-test. In an independent sample t-test, we can see here here the one is independent t-test. So independent t-test useful when we want to compare the two means. It means the two means, the meaning of two means we want to compare the two groups, whether the two groups are the same or not. So here I am using the one picture. I'm showing you the I'm just using the pen. So we will understand the concept of a non-parametric test, that is exit full screen. Yes. Okay, independent t-test. When we want to compare, now in the independent t-test, so what is the purpose of independent t-test? So independent t-test basically we use when we want to compare the two means. So there are, in an independent t-test, we need two variable, one dependent variable, that is y, and another x independent variable. And the condition of independent t-test, the data should be metric, and independent variable, that is it should be non-metric, means categorical data. And there are four types of data. One is nominal, ordinal, interval, and ratio scale. Metric means my question either in interval scale, or the other is ratio scale type question. And non-metric, that is nominal scale question. For the purpose of independent t-test, to compare the two means. For example, I want to compare the salary of faculty members in private sectors, male and female. So my hypothesis that there is a significant difference between getting salary by male and female teachers in private sectors, or I can say male teachers are getting more salary than the female teachers. It's my hypothesis. So I want to test this hypothesis. So what will I do? I will take the two sample, one for a male and another for female. So I am taking 20 observation from the male group and 20 observation from the female. So what will I do? I will take the mean salary of the 20 male teachers and 20 the salary of 20 female teachers. Okay, and then I will compare the two means. And we should keep in mind, when we compare the two means, always we will get the different value, means different mean. But whether this mean is significant or not, this p value tell us. If p value less than 0.05, then we can say the particular group getting more salary than the other group. And initially we frame our hypothesis. One is null hypothesis. In a null hypothesis, we always assume that there is no significant difference between the two groups. But in alternate hypothesis, we assume there is a significant difference between the two groups. Okay. So when we compare the two means, we use the independent t-test, and extension of independent t-test, that is ANOVA. In an ANOVA, there are more than two categories. If we want to compare more than two categories, then we use the analysis of variance. And ANOVA means we need one metric data and another non-metric data. Non-metric means categorical data. Like I want to know whether the science students or commerce students and arts, the perception level of science students, commerce student, and arts, is it same or different? So here I am comparing more than two sample, but in an independent t-test, I am comparing only two sample, two means. Okay. When we compare more than two means, then we use analysis of variance. Now, before applying the independent t-test, we check the normality of the data and homogeneity of the data. So for checking the normality and homogeneity, we need to perform KS test and the leave-in test for homogeneity. If p-value greater than, for assumption purpose, p-value should be greater than 0.05. So if p-value greater than 0.05, it means data is normally distributed and homogeneous. Sometimes what happen when our question, so there are two questions. Question number one, what is your gender? Okay. And second, what is your salary? So there are two, where for applying the independent t-test, we need two questions. One is the what is your gender? It is categorical. The one male and another female. And the what is your salary? Salary, it's a ratio data because it starts from 0. So we check the normality of the male data and female data, and homogeneity also. So if my data normal and homogeneous, then okay, there is no problem. I can test my hypothesis through independent t-test. But if my data not normal, not homogeneous, then what should I do? So we correct our data. We correct our data either log transformation, square root transformation, and inverse root transformation. And then again check the normality and homogeneity of the data. If still my data not normal, not homogeneous, then what should I do? So I use Mann-Whitney U test, which is equivalent to the independent t-test, and this is non-parametric test. And then we can test our hypothesis through Mann-Whitney U test. Same as pair t-test. What is the purpose of pair t-test? Basically, pair t-test we use when we observe same respondents two times, means before the treatment, and after the treatment or experiment. Here the same, for example, there are 10 participants, 1, 2, 3, 4, 5, and 10 participants. So the awareness level before the faculty development program, we observe the each respondent, and after the faculty development program, again we take the observation from each respondent. If there is difference, then we can say the faculty development program enhance the perception level or the attitude, or increase the awareness among the participants. So the purpose of pair t-test, this when we observe two times, before treatment and after treatment, same respondent. So here I am dividing same respondent into two category, male and female. But in a pair t-test, we measure the same respondent two times, before treatment we take and after treatment. For example, you want to reduce your weight and you are joining the particular training program for 1 month. So before joining your weight, we will note your weight. For example, for participants here, the before joining the weight 78 kg, 80 kg, 82 kg, 73 kg, and after 1 month training program, your weight after the 1 month, the weight is 70, 80, or 73, and so on. If your weight significantly reduced, then we can check it through the pair t-test. So, but if pair t-test, the data not normal, then we use Wilcoxon sign rank test, which is equivalent to the pair t-test, parametric test. And the Anova means we compare more than two groups or more than two levels. If my data not normal, not homogeneous for Anova data, then I use non-parametric. I can test my hypothesis through Kruskal-Wallis test. So Kruskal-Wallis test, nothing but same as Anova. The only difference in a Kruskal-Wallis test, we do not check the assumptions of parametric test, because all the non-parametric tests are assumptions free test, and the repeated measures ANOVA, the another when we take repeatedly observations of same participants, for example, doctor take the observation of the patients, same patient, 1, 2, 3, 4, 5 patients. Okay, so after 1 week, after 1 week, after 2 week, after 3 week, after 4 week, when doctor is taking observation repeatedly, measuring the observation same respondent, we use repeated measures ANOVA. The difference between paired t-test and repeated measures ANOVA: in a paired t-test, we take observation before and after, but in a repeated measures ANOVA, we can or we can say it's an extension of a paired t-test. Here repeatedly we can take many times observation of same respondent, means the after 1 month, after 2 months, after 3 months, more than 2. When we take observation more than 2, we use a repeated measures ANOVA. So the only difference between independent t-test and ANOVA: in a independent t-test, we compare the two means, and in a ANOVA, we compare more than 2 means or more than 2 samples. In a paired t-test, we use before treatment and after treatment. But in repeated measures ANOVA, we take several observations many times of same respondents. Okay. Now, when the assumptions of repeated measures ANOVA not fulfilled, then we use Friedman Anova. So I am taking the case study of each test. So I will perform here test the hypothesis 1, Wilcoxon rank sign test, Mann-Whitney test, Wilcoxon rank sign test, and the other is Kruskal-Wallis test and Friedman Anova. So one by one, I am taking the test. So first of all, I will use one sample Wilcoxon rank sign test to test the hypothesis. So it's a case study. Now the company X Tire has launched a new brand of tires for the cars, and claim that the under normal circumstances, the tire life 40,000 kilometer, and a retailer wants to test this claim and has taken a random sample of 10 tires, and he observed the following observation. You can see here: the 37, third was 41,000, and last one was 42,000. So how to develop the hypothesis for non-parametric test when the data is ordinal data and non-parametric data? Then how to test the hypothesis? The hypothesis, the population median is equal to hypothesized median. It means population median does not equal to hypothesized median, but alternate hypothesis says there is the significant difference, or the population median does not equal to hypothesis median. Okay, now I am taking the I am performing now. I think you can see this SPSS. It is visible to all. Is it? Can you see this SPSS sheet? Can you see this data? Is it visible? Please inform me.
Yes, sir. Yes, sir.
Can you see this data set?
Yes, sir.
Okay, okay. Thank you, sir. Thank you. Now I am performing one sample Wilcoxon. I am testing the hypothesis of non-parametric test, that is one sample Wilcoxon rank sign test. So the here the data that is continuous. So the data is continuous. So we should check the normality of the data. So analyze, then descriptive statistics, explore. I'm checking the normality of the data, and then dependent list, plots, and nothing to do here. Options, and exclude cases pairwise, then plots, normality plots with test, and then continue and okay. So this case test tell us whether my data normally distributed or not. So here you can see the data, the p-value of the case test. So p-value of this case test, it is less than 0.05. It is 0.047. So data not normally distributed, data not normal. So we will use equivalent to the one sample t-test. The test name is one sample Wilcoxon rank sign test. So here I am using now the one sample Wilcoxon rank sign test, that is the non-parametric test. I think this slide you can see this slide, and it is visible to all. So I am performing one sample Wilcoxon rank sign test, analyze non-parametric test, one sample. You can see here one sample. So analyze non-parametric test, one sample, and then fields, nothing to do here. Number of tires, I am transferring left hand side box, and then setting. Now the customized test and the compared median. So the hypothesized median was 40,000 kilometers. So I'm writing here 40,000 kilometer, and then run. And after run, I will get the output. So I'm showing you the output of this. You can see the output visible to you. Now you can see the output. The median life of a tire is 40,000 kilometer, and the p-value 0.574. It means there is no significant difference. For checking the significant difference, we need p-value should be greater than 0.05. Now, why the double clicking? After double clicking, the hypothesized median was 40,000 kilometer, and the observed mean means 10 observation. We have taken 10 observation, and that is 41,000. I told you that when we compare the two things, then always we will get the different value. But whether this difference 40,000 kilometer and 41,000 kilometer significant or not. So this p value decides, and the asymptotically significant, the p value 0.574, it is greater than 0.05. It means there is no significant difference. So what was my null hypothesis? My null hypothesis was the there is no significant difference, means population median equal to the sample. Now write this result of one sample test. Now you can see this in this PPT. After reporting the result, how to report our result in research paper. So a one sample Wilcoxon sign rank test indicated that the median life of tires 40,000 kilometer n equal to 10 was not significantly higher than the population median 40,000 kilometer. Okay, because this difference is not significant. If difference 40,000 kilometer and 30,000 kilometer, there may be possibility that the difference was significant, but 40,000 kilometer and 40,000, it's a by chance, it's not the significant difference. Okay, now the second case study, it is related to the Mann-Whitney U test. So I am taking the I am sharing my another slide, the Mann-Whitney U test. I am opening the file Mann-Whitney U test. So I am sharing the data set of Mann-Whitney U test. So in this Mann-Whitney U test, basically it is equivalent to the independent t-test. Here doctor is giving, doctor selected 20 people, and the one group, he is giving ecstasy tablet to the depression depression patient, and 10 people he is giving the syrup. And doctor wants to know which medicine, which whether syrup will work or the tablet. Okay, so there are two groups. One is in a 10 people, doctor is giving ecstasy tablet to the 10 patients and measuring the depression level next day. Okay, so this is the depression level after giving the tablet. this is depression level of the 10 participants, and the another 10 people doctor giving syrup, and the syrup, and then measuring the depression level of the 10 participants. So here we want to know whether the ecstasy tablet work more effective or syrup. So through Mann-Whitney U test we can check it. So what will we do here? So I am performing the Mann-Whitney U test whether the ecstasy tablet effective more than the syrup. So initially, when we they frame the hypothesis in a null hypothesis, we assume there is no significant difference between ecstasy tablet and syrup. Means both drugs work equally. Okay, but in alternate hypothesis, so we frame our hypothesis. No, there is a significant difference between the two doses. Okay, so we perform the non-parametric test, analyze, then non-parametric test, legacy dialogues, and two independent samples, and then types of drug. Here define groups. There are two groups, one ecstasy tablet group, the coding for one, and another syrup, and then transfer this variable. And by default, you can see here Mann-Whitney U test, and just press the OK, and then we will see our results. Now this is our now you can see our result here, the results. So you can see here ecstasy tablet, the mean rank 15.10, and the syrup, those who are taking syrup, their depression mean rank, that is 5.90. So depression level less in syrup. And so here whether the 15.10 and 5.90, is it significant different or not? So I told you many times, when we compare the two groups, always we will get the different value. But whether this difference significant or not, who will tell us? This p value, asymptotically significant value, tell us. And here the p value is 0.00, means less than 0.05. So we can say the syrup more effective than the ecstasy tablet. Although this is a hypothetical case study, it is not and the third case study related to Wilcoxon rank sign test. The Wilcoxon. Now question is how to report the result of report the result of Mann-Whitney U test. So you can see here the slides. So we developed the hypothesis for non-parametric test. So there is no significant difference between ecstasy tablet and drink syrup for overcoming depression. Means both the drugs equally effective for reducing or overcoming the depression problem. Okay. Now the alternate hypothesis we will frame like this. There is a significant difference between ecstasy tablet and drink syrup overcoming depression. Now how to report the result? In a research paper or thesis. So ecstasy tablet users, the median value of this were significantly more depressed than the other group. Okay. Now I'm taking another case study. The case study Wilcoxon rank sign test. Now you can see the data set of Wilcoxon rank sign test. In this case study, there are 10 people who are facing the problem of the stress. Now the stress, before taking the prescription, the stress level was 16, 15, 20, 15, 16. Okay. And after the prescription or taking the medicine, the depression level is 5, 6, 38, 9. So we want to know whether this medicine significantly reduce the stress level of the person or not. Okay. So from the data, we can see the depression level is reducing, except the case number 3. Its stress level increasing after taking medicine. But although all cases we can see here the depression level decreasing. Okay. Now whether this difference is significant or not. So in this non-parametric test, Wilcoxon rank sign test, we frame our two hypotheses. One is there is no there is no impact of this particular medicine. So here, how to develop the hypothesis for non-parametric test, that is Wilcoxon rank sign test. There is no significant impact of drink syrup on reducing the stress. Stress, we cannot reduce stress through syrup, drink syrup, but there is a significant impact of drink syrup on reducing the stress. Okay, now I am performing the Wilcoxon rank sign test. So here the Wilcoxon rank sign test, you can see this slide. So this is data I'm performing, analyze, then after analyzing non-parametric test, legacy dialogues, and two related samples. So I'm checking both the variables simultaneously, selecting both and transferring right hand side. And by default, you can see Wilcoxon, nothing to do here, and just okay. And p-value tell us whether this particular dose significantly working or not. I'm just clicking OK, and then I'm showing you the output of this output. You can see here there are the rank 5.22 and another 8. So whether this mean rank different significantly or not, so through this p-value we can say there is a significant impact of dose reducing the stress level of persons. So p-value that is 0.047. So now question is how to write this hypothesis and result of the Wilcoxon rank sign test. So I am performing here. Now you can see the how to write the hypothesis of the so the I am sharing the PPT to explain. Yes, the how to report. So how to develop the hypothesis for Wilcoxon rank sign test. There is no significant impact of syrup on reducing stress. And the reporting result, how to report the result. For drinking syrup users, the depression level was significantly lower than the Wednesday than the Sunday. So इस तरीके से we can report our results. Now I am taking my fourth case study, that is Kaushal-Wallace test. Kaushal-Wallace test. In this case study, there are 4 categories, and 4 categories. We want to know whether coffee consumption increases heart rate score or not. So we created 4 groups. So one group we are not giving coffee and measuring the heart rate score of the 10 persons, and another 10% we are giving 1 cup coffee in a the month, and after 1 month we are measuring the heart rate score of the 10 people. And the third category, that is we are giving 2 cup coffee per day and measuring the heart rate score of each people. And the another is 4 cup coffee, we are giving 10 people 4 cup coffee per day and measuring the heart rate score. So here we are comparing basically we are comparing the more than 2 mean ranks. So here why no cup coffee, the one level, and the another level we are giving 10 people 1 cup coffee, and another 10 people we are giving the 2 cup coffee, and the other people we are giving the 4 cup coffee. So total participants here 40, 10 in each group. So we want to know whether the 1 cup coffee, 2 cup coffee, 4 cup coffee significantly increase heart rate score or not. Okay, so I'm just checking this hypothesis. So how will I do it? So through Kaushal-Wallace test, I can perform the Kruskal-Wallis test, analyze, non-parametric test, legacy dialogues, and K independent samples. K means more than 2. And then coffee consumption in the defined groups, and there are 4 level, 1 to 4. So I'm just ticking, sorry, 1, and the maximum is 4, and then continue heart rate score here, and then Kruskal-Wallis test. Okay, and after okay, I'm showing you the output, whether the significant difference or not. So here we can see the no cup coffee, the mean rank 10 point, 16.35, 19.65, 14.65, 13.35. Whether this difference significant or not, who will tell us? The p value, asymptotically significant p value. It is 0.006, which is less than 0.05. So we can say there is a significant impact of coffee consumption to increase the heart rate. But we do not know whether 1 cup coffee significantly increasing the heart rate score, 2 cup coffee increasing heart rate score, or 4 cup coffee. So to check this, we create the 3 pair. One pair we will compare no cup coffee with 1 cup coffee and apply the Mann-Whitney U test. Then another pair, no cup coffee with 2 cup coffee, and apply the Mann-Whitney U test. And we will create another third pair, no cup coffee with 4 cup coffee, and apply the Mann-Whitney U test. So to check the significant impact, we will perform 3 times Mann-Whitney U test, which particular the level giving the significant value. So I am performing 3 times Mann-Whitney U test to independent samples. The coffee consumption here, heart rate score, and then first of all I am comparing group 1 with group 2, and then okay, and the second time I am performing the the analyze, the non-parametric test, legacy dialogue, 2 independent samples, and I am comparing group 1 with group 3, means 2 cup coffee, and the last is 1 cup coffee with 4 cup coffee. So analyze, then non-parametric legacy dialogue and independent t test, coffee, define groups, and 1 cup coffee with 4 cup coffee, and continue, and then okay. Now I'm showing you the only 3 results through output of SPSS. Now you can see when we compare the 1 cup coffee with no cup coffee, no cup, or 1 cup coffee, there are 2 groups. So mean rank is 9.4 and 11 points. So there is a different value. But whether this difference is significant or not, who will tell us this p value? And asymptotically, p value, that is 0.404. It means the 1 cup coffee does not increase significantly heart rate score. So there is no significant. Now we compare no cup coffee with 2 cup coffee. The mean rank is 10.25 and 10.75. So we can see here it's a different value. But whether this difference significant or not, who will tell us this p value? And the asymptotically p value 0.850, which is greater than 0.05. It means there is no significant difference. It means you can take 2 cup coffee per day too, and it will not increase significantly your heart rate score. Now the other compare third group, the 7.3 and 13.30. Although we can see here different value, but whether this difference significant or not, this p value tell us here, and the p value is 0.034. So we can say there is a significant difference. Okay. Now my last case study, that is Friedman Anova. So Friedman Anova, I am just opening the file of Friedman Anova, because the Friedman Anova, the last is Friedman Anova, that is, yes. In this, yeah, I'm showing you the file. There are 3 groups. In the group 1, they want to, there are 10 participants. They want to reduce the weight, and at the beginning, the weight is 63.75, 62 point. And after 1 month, the weight 65.32 and 18.34. So it's a case of a repeated measures ANOVA. We are measuring more than 2 times same respondent. So because my data not normal, not homogeneous, that is why I'm using the non-parametric test, that is Friedman Anova. Now, how to perform Friedman Anova here? Analyze, non-parametric test, legacy dialogues, and the two care-related samples. And I'm selecting all the three variables and transferring in the right-hand side. And then by default, you can see Friedman, and then just OK. And after OK, we will get the output. So I'm showing you the output. The weight at start 1.90, weight after 1 month 2, and weight after 2 month. So it is not decreasing, it is increasing. But whether this training program successful or not. So initially we frame our hypothesis, this training program reduce the weight, but alternate hypothesis, when we will say in a null hypothesis, there is no significant impact of the training program to reduce the weight. But alternate hypothesis says no, there is a significant impact. But here we can see the p-value, that is 0.905. So weight is not significantly reducing. So this is all about the non-parametric test. So thank you very much, because in a 1 hour we cannot take the all issues. We cannot cover the all issues. So it's just idea, or if you want to go to detail, then you can watch my videos. You just in a detail the name Dr. Shailesh Kaushal on YouTube. So you can see the video, and then if you have any problem, then you can. I have given you my contact number also. So thank you, madam. Thank you very much.
Thank you, sir.
बिकॉज अभी मेरा मीटिंग भी है 2 बजे, इसलिए मैंने थोड़ा सा इसको जल्दी से कंसाइज कर दिया है.
It's okay, sir. No problem. I'm here to propose vote of thanks of the fourth session. Dr. Shailesh Kaushal has delivered very fruitful lecture for us. He has spotlight on the hypothesis testing using non-parametric test with an examples. On behalf of organizing committee, Sadhguru Gadge Maharaj College, Karad, in association with HRDC, Savitribai Phule Pune University, I am thankful to Dr. Kaushal, Assistant Professor, Department of Business Administration, University of Lucknow. I am also thankful to all the participants for their presence virtually to this session. So this session is over here, and soon the next session will start. Thank you, sir.
Thank you, madam. Thank you.
Thank you, sir. Thank you, Dr. Kaushal, sir.
Thank you, sir.
Thank you, madam.
Thank you.